I started out with
I'm always too tall for these, and I have to slink down to get close enough. Thanks for joining us for the January meeting, 2020. Welcome, Happy New Year. We're enjoying great weather, and we have a great turnout as a result. I'm Jeff Cohen. I'm your New York chair. Thank you for coming. And I just have a few quick announcements before we get started. Tonight's meeting is building television systems in a time of multiple technology transitions. And I think you are all familiar with what that means. First off, we always begin by thanking our sponsors. This year we have 25 sponsors who sponsored prior to the end of the year, but that process continues throughout the year. So if your company would like to become a sponsor, we have 2 tiers of sponsorship, and we appreciate your sponsorship. It allows us to operate this section. So the logos are on the website, the names are on the website, and we'd like to see you there as well. And Carl Cavagnolo runs the sponsorship this year. So there's his contact information if you want to reach out to him. The info is also on the website. Half the people here this evening are members, and half are not members. This is your professional society. It's what provides the standards for the industry. It's the local sections allow us to learn about those standards and to get to know one another as a community. We've been doing this for about 104 years. We need your participation. We'd like you to join. So your badges indicate whether you're a guest or a student member or an actual member. So please take a look at the badge to the left and right of you and encourage your neighbor to join. Thank you. As a quick glimpse at our upcoming meetings, February, which has no venue yet or date, will be announced shortly, but that will be on lighting. That's a February. We've been doing every February lighting. March, we're going to do a deep dive on the post-production workflow for Apollo 11 at Final Frame. So more to come on that. April, we do NAB, so we don't have a meeting, and we do our May NAB wrap-up, which will be at Able Cine in Brooklyn this year. And then June will be the ARQ RIST meeting. We're going to look at some video over IP technologies at AT&T. All right, just a quick glimpse at the SMPTE-NY webpage. You can get to this page either by navigating through the SMPTE.org site or directly to it via SMPTE-NY.org. And I just want to point out a few things here. On the left of the skyline image is an icon you can now click on, and it will open a form that allows you to suggest a SMPTE-NY meeting. It will automatically go into the list that the New York Board of Managers will consider. So that's a great innovation. And then on the other side, the right-hand side of that skyline is a link where you can now add your name to our mailing list. So for those many people who complain that they no longer get meeting notices, go there, click, and you get meeting notices for any section in the country that you want to. So that's another innovation. I'm now going to introduce Josh Gordon, this evening's producer, and he's going to take the reins from here. Thank you very much.
Okay, well, my first order of business is to welcome Patrick Murray from Cisco to give you a warm facility welcome.
First of all, just some logistics for, I'm sure everybody want to know this at the break. The ladies' room is right off to the left as you go out the door. The men's room is corresponding on the other hallway. If you just go back towards where you came, towards the front, it's right there on the left. So just wanted to say on behalf of Cisco, welcome. We thought when you were looking for a venue, we had a great location, midtown, above the train station, plenty of room, and now it looks like we don't have enough room, which is a good testament to the interest in tonight's event. So I just wanted to say a couple of things. One is looking at the agenda tonight was pretty interesting. One of my colleagues has taught me that one of the constants in the media business is things never stop transition, right? So I'm sure you've all been through many, many transitions, but it was really interesting looking at the agenda on how many transitions are going on concurrently right now. And in fact, I think the comment was, maybe there's more that we need to talk about. So at Cisco, we're really excited about a couple of these. One in particular is obviously the transition to IP. It's something that we're heavily involved with in terms of our innovation and work with customers and partners. The other is virtualization, actually, because it's not necessarily all about public cloud. So we're doing a lot of work there. But I would just say that if there's things that anybody here thinks that we should be doing, we're all ears. I had a number of interesting hallway conversations coming up about suggestions, things Cisco should be doing to help the transition in the industry. Love to get that input because we'd like to do our part. So let me do a couple of introductions. I just realized I didn't introduce myself, so I'll start there. So I'm Patrick Murray. I'm responsible for U.S. media sales and business development for Cisco. There's a couple of colleagues in the room that I wanted to point out that will be here probably for the entirety that can also take input. So over in the corner, sitting up high, we have Rob Covington. Rob runs our engineering team. So the systems engineers that deal with all the customers and partners in the media space. That's Rob's domain. Straight ahead, we have somebody probably a lot of people know, Jacob Jeevanagam. Jacob's a longtime veteran in the media space. He comes from the scientific and he runs business development for us. So he's the interface to a lot of the industry folks and what we're doing, with our various partners, many of whom are here. And then where is he? Amar. He's probably in the lab near him. And then for those of you that don't know, Amar Latif, he's the principal engineer. He's our principal engineer and lead architect for everything we're doing in media. He's really the gateway between what we're hearing from the customer and the industry into our development organization. And a lot of the innovation that we've come up with over the last couple of years, Amar has been in the middle of driving that. And I know many of you know. Oh, I'm sorry. Okay, so with that, I don't want to take away any more time away from why you came here, but I just want to thank everybody for coming and hope you have a good event tonight.
Thank you, Patrick. So that leaves it to me to introduce our panel. We've got a great panel, and there's a little story behind how they all kind of came together. But I think most of you know who these folks are. Carl Paulson is the CTO of Diversified, the largest system integrator in our space. John Turner is extremely well known in the Northeast. He's kind of the go-to guy. If you have a problem no one else can solve, he's your man. John Myatt is, of course, with Magic Communications, but I always think of him as the editor of the SMPTE-2110 standard. It's hard to get around that accolade. And Mark Shubin is a ubiquitous force of creativity and knowledge in our industry. And a year ago, when I introduced him at another panel, I looked him up on LinkedIn and it said, defies description. And I thought, that's pretty much appropriate. So in the promos, I just put him down as Mark Shubin will be appearing as himself. So Mark Shubin. John Humphrey brings an interesting angle to this. If you look at his resume, he's worked for a series of system integrators throughout his long career in this industry. So he brings a different kind of perspective to this kind of issue of all of these different technologies and transitions, and how do you build them into one consistent facility. It's a challenge. So how did this all happen? So let's, oops. Okay. Basically, it's easy hindsight is 20/20. But the question is, what are we going through right now? I mean, everyone I talk to says, oh, there's this transition. And some people seem to be focused on one more than the other or than the other. But the truth is, if you take a step back, there's more than a dozen going on. And you saw the list on the promos we sent out. And I got calls from a lot of people who said, hey, you forgot one. And it just isn't that hard to add another 3 or 4 to that list. There's just a lot of change going on. And right now, we're in the middle of it. Sometimes it's hard to know what's going on around you. So what I did is I tried to find the smartest people I could find and figure if we ask them a series of questions, maybe we can help them see through the haze and try to understand where we are at right now, so that 5 years from now, when everyone says, well, didn't turn out the way you thought, but here we are, and this is the way we build facilities now, but okay, that's fine. But what would we think of then of how we're looking at things now? So that's the basic idea that we're going to try to attack. Okay. So this all started back when Carl Paulson rolled into town last year with his truck full of SMPTE-2110 gear, and we all tried to understand what it all meant. This was a year ago, and Carl got up and gave an introduction, and he talked about what it took to integrate all of these different suppliers, different technologies into one seamless working demonstration that you can put in a truck that actually is that big and roll it around the country. So that was a pretty exciting presentation and got a lot of us in the SMPTE New York chapter thinking about, boy, this really is a challenging time, maybe more challenging than normal. And then I was talking to John, I better mention this. We actually have 3 Johns on our panel. So later on in the presentation, we're going to ask people to ask questions. And would the 3 Johns raise their hand, please? Okay. So we have John Humphrey, we have John Myatt, and we have John Turner. Okay. So when you think about who you want to ask the question and which John it is, just try to remember which one or point, or we'll figure it out, but John won't do. We're going to have to be a little more formal and use first name and last name, I guess. So, okay, but anyway, John Wyatt, I'm sorry. So it was John Turner. I was talking to him and he said, yeah, there's all those transitions that Carl Paulson talked about. And he said, I was building a facility for a major broadcaster who shall remain nameless, but it took us 6 months to decide about using just one of these technologies in transition. I said, 6 months? He said, yeah, we had to go back and forth. There were many parameters to evaluate, and that was just one transition. Okay, what if you're building a facility from the ground up and you've got to work your way through a dozen or more of these transitions and evaluate which one of these new technologies are attractive sounding science fair projects, which ones are mature technologies, which ones are worth taking a risk on because maybe they're not fully cooked, and which ones do you think your staff can support? So from that conversation, it kind of got me thinking that maybe we needed to take a look at this. So oops. Let's skip ahead here a little bit. This is, okay. Well, anyway, let's, okay. So anyway, okay, so we have a series of questions. The way we're going to work this is I have a series of questions that I've interviewed all these good people, and we're going to start with a few questions just to get things rolling. So for the first half of the evening, what I'd like to do is just have these folks do most of the talking. But after that, hopefully we'll stir up a lot of interest and a lot of curiosity among the audience, and that's when I want you in the audience to start asking questions of these guys. And just remember, there's 3 Johns, and we'll just make note of who said what and direct your question accordingly, and we'll try to get more of a dialogue between the panel and the audience. So, okay, that's how we're going to work this. So, let's see. So there really is a list of over a dozen technologies in transition. Which technologies should system integrators build into their next facility? With over a dozen technologies at play, is it practical to embrace them all? Tonight, we have an all-star panel to address this question and many others that could collectively give us perspective on just where we are at today and where we will be 5 years from now in this rapid period of change. 5 years from now, when people look back at this moment, what will they say? There were many critical decisions to be made about many new technologies. The collective sum of all these decisions will determine the kind of facilities we build and the kind of technical environments we will all work in for years to come. So this is an important conversation. All right, so what I'd like to do is start off with John. That's right, Slap John, yes. What I'd like to do is start with the John who is about this quote here. And John Turner, who's the one who told me it took him 6 months to decide on just one of these technologies. So, John, if you could tell us that story.
No, it wasn't my money. But, this was for a major organization that has a lot of very smart people in it. And when you work with a group like this, you get many, many strong opinions about things. So 2110 was around the corner. I don't think John had finished writing his papers yet, but we were looking at everybody that was involved in the field and wanted to see if we could jump up on technology. The problem we had was manifold. First of all, we recognize that 2110 is going to be more expensive than doing anything with SDI on a port-for-port basis. You've got to, for 2110, we're building two systems, not just one. And I don't think anybody in here has ever built an SDI plant with two SDI routers in parallel. So anyway, that was one decision. The second one was physical space. We had a limited amount of room, and we thought about it and did some sketches and figured out we need about 4 racks full of converters if we wanted to use IP switching. And at the end of the day, that sort of straightened things out, especially when we added up the cost of the converters. So it was built as a 3G SDI plant, and it went on the air on time, and it's working great.
So you decided not to go with 2110?
No, we did not. And the other thing is that we had a space limitation on the plant. There wasn't much possibility that these people were going to grow. They were in a very high-priced neighborhood, and by the time they would get around to thinking about expansion, the rest of the space around them would have been rented. So it's fine. I mean, we have 2 studios in there, insert stage, big radio complex. And it just works great. The router's fine. One thing we did do in the middle of the project, it started out 720, and they said, oh, how about 1080p? So that was great. And all that took was the little dongle from Sony for $15,000 to plug in the side of the camera to make the camera do 1080p. The second thing that happened was in the middle of all this, one of the shows that was coming in decided they wanted to do 24p. So that turned out to be not so difficult. The problem we had was choosing a converter that wouldn't correct the picture. We had a whole bunch of these things come in. The transport out of this place is done over 40 gig Ethernet. It's IP, it's 40 gig. Works fine. But the telecom equipment isn't capable of being reconverted, reconnected, or changed easily. And this was rented from a big telco, and there was no reason to call these guys 3 times a day to flip things back and forth. So we use converters to take the output of the 24p service and convert it to 1080p 59, and it works fine. It looks good on the air. You can tell it's definitely got the film look. Not that you like it, but and sorry guys, I know there's a motion picture part of this organization, but basically that's what we did, and it's been rock solid.
John, that was 3 years ago.
Yep.
Are they still happy with the facility even though
yeah.
there were technologies around?
Oh yeah.
Okay, how come? They're not
Well,
IT envy or?
when you build these plants and it becomes stable and the workforce is acclimated to it. And that was another thing that we did. We talked about staffing. And at the time, they were planning to use NEP as a production manager, which they did. And they didn't have the opportunity to spend 2 months or 3 months looking for a guy with a CCNP or a CCIE. So we had to use people that had been familiar with classic television equipment. And there's been a couple of change outs of the engineer in charge, and not a problem. It took a guy maybe a day to get used to the facility, but everything is on macros. It's very easy to flip the facility around to different modes. And it's, I don't think anybody over there is thinking about this, the architecture under the hood. Because it works, they're worried about, who's going to be on the air tomorrow.
Well, they should.
Yeah.
Good. Well, thank you for that. Carl, when we talked, you mentioned that one of the things that makes this stuff a little more complicated for each one of these transitions is, okay, you pick the technology you want to use, but it's no longer straight ahead. Now with all the new flexibility you have with IT technology, there are more than one way to do the same thing with the same technology. So that adds a layer of complexity because you're sitting there as a system integrator talking to a broadcaster or a television organization, and they're saying this is what we need, and you're saying, okay, we can apply these technologies, and these technologies are in transition, we can use them. But the minute you say that, you can say, but there's more than one pathway. We can go to work doing it. How does that actually play out in the relationship? How do you handle that in a conversation with a customer?
There's a lot of components to answer that question, just like there's a lot of technologies you can probably choose from.
Yeah.
The most important thing, I think, in a general statement is that don't do something just because of the technology. Solve the business problem. Look at what you need to do from a workflow standpoint. And then you have a choice of technologies. And that's frankly one of the major issues, is that in many cases they don't know what the workflow is. So you begin at that point to start describing the details of what's needed to be done, what are the distances, how many floors in the building does it have to cover, and things of that nature. And that begins to start the process of the design parameters themselves. And then the other part of it is time, or an expectation of time. Some of the newer technologies are certainly stable. We could call them stable. That's a word that's used in the industry to describe certain statuses of things. But when you really start gluing them together and you put one part to the next part to the next part to the next part, you find out that maybe they aren't all totally stable together. You have to really do a lot more thinking about where things are applied in the system and how you're going to use them in the workflow. But frankly, without a good definition of workflow, you can go in any direction you want, and we'll keep coming back to a cul-de-sac or an endpoint that doesn't work.
Wow. You mentioned the word, everything works pretty well until you realize they all have to work together. Could you expand on that a little bit? That seems to be the core job of a system integrator. You're taking many technologies and integrating them into a workable solution.
Well, certainly, when you think of the number of components and the number of working systems and the number of flows, we'll pick on IP since it seems to be a more prominent one right now. There's a lot of different areas that have to be addressed. A simple one might be a good example of one would be audio. Audio systems in place right now are very prominent, using either a Ravenna or a Dante or type format, which isn't 100% compliant from an endpoint to endpoint perspective with the other ST2110 standards and suites. So at some point in the time, you've got to jump out of one particular format to another particular format. And how do you do that? There's lots of different ways of doing it. And many times the end users want to pick the one throat to choke approach to things. And so they'll pick a vendor that maybe has 75 to 95% of all the products that you need to do that. Oh yeah, but they don't make cameras. So what do? Now you go to a camera manufacturer. Pretty straightforward from a 1080p 5994 or 1080p 60, but oh yeah, we want to do 4K. Now you've got two prominent, actually three different methodologies of just doing 4K alone. You start to see, you put all those pieces on decisions on a piece of paper or alternatives on a piece of paper, and you've got a pretty complex matrix that you have to go through at the beginning. And what usually happens is partway through it, someone comes up with a budget. And the shock factor hits them, and all of a sudden you pull back and rewind and go a different direction. So I mean, that's a system integrator's job, is to pick the right components, pick the right time frame, help them describe what they want to do, and then go forward. Yeah, sometimes. And then the time part of it is John Turner's example was pretty good in that maybe SDI was a better way to do it. And if it's a project that you want to have up and running in 4 to 5 months, I'd stay away from IP right now. If you've got a lot of time to plan and engineer it, and you can build a sandbox and learn it yourself, because not only do you have to build it, you got to maintain it too. So there's a steep learning curve for this right now. I think it's going to get a lot better in a couple more years. There's going to be enough systems out there, a lot of sharing, just even like what we're doing now, that people won't have to learn from square one. They'll learn from maybe third base. It just becomes a home run.
Wow. Carl, how does this change the relationship that you have with television organizations? These the systems you're proposing, when they're the IP variety, are way more complicated. There's more variables. Is it just pretty much business as usual, or do you find that there are more conversations, more things to talk about, or is this just the sort of thing you've always done all the time?
Well, I think if you pick the SDI world, that was fairly well understood. I mean, the standard was written, Merrill can correct me if I'm wrong, 1986, thereabouts. And products really came around in 1990, but we kept changing SDI, adding things to it, modifying it, whatever it needed to be done. Although the transport was pretty stable, all the peripheral gear, the ecosystem that surrounded an SDI environment continued to evolve and still evolves. And we're going through the same thing with IP. It's the whole ecosystem you have to consider.
We did have that 216 megabit glitch for a while there.
Okay. All right. If we could just run down, have every one of the panelists make a comment on which technology transition they think is going to be the most challenging, and 2 questions. Pick one technology that you think is most challenging for broadcast and television facilities to deal with, and then also tell us if you think we're in a period of radical change where everything's changing, or just describe the state of play as you see it. Is it abnormally high? Is it pretty much routine? How would you describe it? And why don't we start with John Humphrey here, and then why don't you go first, and then why don't we start back with Carl and come back this way?
Well, I certainly agree with the statements Carl made about system integration. Carl and I worked together at one point. I worked for Hitachi making cameras. That's a relatively simpler thing. We start everything, but we're not in the middle where we're trying to patch things together. We have ST2110 on the output of the CCU of our cameras, but mostly what I've been involved with is HDR. Now, today, everybody knows, well, I think, what HDR is, what it does, the different profiles that are available, and things like that. From a system infrastructure standpoint, HDR requires 10-bit. If you have a codec that's 8-bit, that's the end of it. Obviously, broadcasters can't do HDR at this point. 3.0 obviously will do HDR. I'm making a presentation at this coming NAB on full HDR, full HD HDR. Much of the industry is finding that there's far more improvement in the picture using full HD and HDR than 4K without HDR. And you have the benefit of greatly reduced bandwidth, costs, delivery, storage, Every part of the professional side is dramatically affected, bits or bucks, by using 4K and HDR when people sit too far away from their TVs at home to see the full resolution of 4K anyway. Bernie Lecter from RCA years ago established 9 feet, Mark would know this, as the standard viewing distance, and it's 3 meters worldwide. And what's interesting, I should let Mark take over here, is that, you know, we were watching 24-inch CRTs back then, and yet we still sit the same distance from the display. And now the display 65 is common, and we're going to 70 and 80-inch, where maybe you could actually see the full resolution of 4K at that point.
Okay. Carl, why don't you tell us the one area that you think is going to be the most challenging of all the transitions we've mentioned?
Well, I think we've mentioned what two so far.
Oh,
Maybe three.
all right, I guess.
You've got a plethora of them.
Yeah.
You know, what does 5G going to mean for the world in the future? That's certainly a challenge because it's an emerging technology. It's only in certain areas, there's only certain applications. But for example, at the CES conference last week, NBC and Sony and Verizon have partnered together to put literally a cell phone, if you will, on the back of a camera and run it around a stadium using 5G, 5mm technologies, where it used to take microwave channels at 2 or 6 or 7 gigahertz rather, and heavy duty gear, an antenna system that had to be tracked, those sorts of things. So there's a case right there where that might solve a problem, but it works in an arena, but it probably doesn't work on a golf tournament yet. I mean, just those sorts of things. So you got to understand what the technology means, and then you've got to figure out where the application is and go from there. So that's probably the hardest part, is to know enough about the technology and then know about where to apply it. And that applies to all technology.
Okay. John Turner, which of the technologies in transition that you deal with do you think are the most challenging?
Well, I think they're all challenging, but the one that we're particularly familiar with is ATSC 3.0. We've been working with it now for about 5 years, and some interesting things have happened, very much similar to the Grand Alliance days. You got to remember that the ATSC 1.0 standard we live with today, I'm finally glad that Sinclair has stopped screaming about it, because they're going to get their standard finally. But this was designed by, or was specified by ACATS, which was an FCC appointed committee, and the direction was to replicate the analog service area of all the broadcast stations, not exceed it, but replicate it as close as possible. And out of that came a DSP modulation, which did exactly that. It replicated the coverage area. Now, ATSC 3.0, offers, besides all of the features that it offers, there's about 20 specs, by the way. There's 20 parts of the standard. Each one is very complex, but if we stay with the RF side of things, what we're doing there is using a modulation system that traces its roots back to cell phones and DVB-T2 and other and satellite communications, and they've taken advantage of these things now. This gives the broadcaster the ability to modify the modulation type and the code rate. And when you vary those two parameters, you can transmit. You can pick a variable and watch what it does to everything else. So you can say, for example, well, I want to be able to have people receive my broadcast on their cell phone, 2 floors under the ground. So you can set this thing up to have a carrier to noise ratio of 0 or 1 dB, and likely that will work. And at that bit rate, maybe you can transmit 3 megabits. You can easily do SD on it. Now, on the other side of the equation, it gives us the ability to do 4K, and we've done that. It works like a charm. We can go to 4096 QAM, which is an unheard of depth of modulation, but that's going to require a really clean channel to receive. That will probably not work with the coverage area that people have today. One of the things that I read this last week was an article written by two Carnegie Mellon professors talking about a problem that they see with this. And this problem, I think Merrill, you've been on top of this with that FCC thing you filed. And this problem is that now that the broadcasters have the ability to change their modulation to anything they want, the coverage area is going to change. So this particular engineering article talked about Pittsburgh. And they talked about KDKA and a station in West Virginia that also carries CBS. And the issue there was the worry that if KDKA uses a robust modulation scheme on their system, that they could easily overlap the West Virginia station and vice versa. And now you have a situation where you have multi-video program delivery services, cable and satellite, who have the ability now to negotiate with competing entities. So, if you've got two stations that are carrying CBS network, you can pound the cost down on these guys. So, there's an issue there to think about, and that is, how do you protect these stations? And their financial base these days is highly dependent on retransmission revenue. So this becomes a problem. But it's a very complex and great standard. We did an SFN last year at the NAB. Worked better than I expected. We had a dongle that was made by Bonnie Beeman's company called Airwaves, and it plugged into the side of a Microsoft Surface, and we were able to walk all over the North Hall, out into the lobby, pretty much down to where Sony's exhibit is, and we didn't lose the signal. We were using 20-watt transmitters, backed off, because one of the things about ATSC3 is the peak to average power ratio is a bit more significant than it is with ATSC1. But I think we're going to have a lot of fun with ATSC3.0. And one more thing. The FCC, of course, has just finishing the repack. It's pretty much done in New York, except for Channel 13. There's no channels left. In Las Vegas, there's no unassigned channels between 14 and 36. Everyone's got a station on it, which made last year's NAB very interesting.
Okay, let's moving on to the next John Myatt. The technology you think is going to challenge most, the technology in transition you think will challenge people most?
We keep talking about technology, but the slowest evolving part of all these systems is not the technology, right? It's the people. And, historically, when you built a facility, you had all kinds of engineering limits. The size of a router before it got expensive was only so big, so that drove you to divide things up a certain way. The SDI cable could only go so far, so that drove an architecture decision that you would do things a certain way. There were all these technical constraints that then drove their way into the roles of people and the organizational boundaries and this studio can't talk to that studio kind of decisions. Well, the IP systems and some of the other new technologies, they remove all these constraints. And so now you're in a situation where, we could engineer anything. If you wanted everything in a facility to be able to talk to every other thing in a facility, okay, we do that. And that many people ask for that, but it just forces the hard transition, which is really deciding, okay, what is the optimum workflow for the business? What are the roles of the people? When the people aren't constrained by all these technology barriers, what are the roles of the people? Do you actually need the production control room to be right next to the studio? Do you actually need the cameras to all be available to everybody? I mean, it sounds neat until you start thinking through, that means you could accidentally take that camera in the maintenance shed to air. Is that good? It's good in what was the movie with the under Madison Square Garden where they blew up Madison Square Garden. And that one, they took a maintenance camera to air. But it was unusual, right? So it's a different, the problem is not the technologies, right? The problem is really that you don't have these technology constraints as much anymore. Now you have, like John talked about, all this flexibility, which is great, but it creates legal problems, it creates people problems, it creates marketplace problems. And in the case of, television creation facilities, it creates opportunities to do things differently. But oh my God, a clean sheet of paper on how we do things, that's hard, right? And it's not a technology problem. Now it's technology stops being the constraint and you get to actually think about what's the right workflow for the mission of the organization, which is not an engineering problem necessarily.
John, how do you think this is going to work itself out? 5 years from now, will there be certain well-traveled workflows that sort of become accepted and people kind of say, oh, let's go with that approach? And other ones, maybe a few people try and go off the cliff and
I have to assume that, yeah, we'll develop a new normal, right?
Yeah.
And we already see that at the technology level. Like when you build an SDI plant, there's things you don't even write down because everybody knows that, signal comes out the top of the patch bay, it goes on the bottom, things like that, right?
Yeah, yeah.
And IP, I was in a project where people spent hours across multiple meetings arguing over how to label the cables.
I've been in those meetings.
Because, in SDI, the cable says where it came from and where it went to. And in IP, neither of those two things is particularly relevant.
Wow. Huh. So is it just about establishing what's normal and best practices, or is it something inherent about the technology that is throwing people?
Well, the technology is less constrained, right?
Right.
So now workflow and roles of people and model of organization and who's responsible for what, it isn't driven by the technology constraints. Now it's driven by some other set of non-technical factors like actual efficiency and capability and what's the right way to do it from a content production standpoint.
Wow. Okay. Mark, let's see. You are going to be the bane of our existence, your T-shirt says. So tell us what the worst or the most challenging technology in transition you see on the forefront today.
To me, it's the audience.
The audience.
The audience is the biggest problem we have because we need to get the audience to watch and listen to what we're doing, and we want them to get it the way that we want them to get it, which they won't necessarily do. This round of questions started with John Humphrey, and he was talking about how HDR is wonderful. And I agree, HDR is quite wonderful. But those of you who followed Game of Thrones last year might have seen things like the people in New Zealand saying, this is what it was supposed to look like. The people at home did not see what the people who made it wanted them to see. And that was a problem for the audience. So we need the audience to catch up with what the rest of us are doing.
Do you think the audience is dissatisfied?
The audience may not be more dissatisfied than they were in the past, but my old boss, John Goberman, used to talk about how if you want the greatest diversity of programming, you have one channel. So BBC, when they were the only television channel, could put on a nun talking about the fluffiness of pubic hair in classical painting. And people would watch it because it was the only option. When you went to 3 channels, then people would sometimes watch what they wanted to watch, but they would more often watch what was least objectionable to them. And one of my other bosses, Paul Klein, came up with the theory of the least objectionable program, and that was what would win the time slot. You would do a lap around the dial, and those TV tuning was with a circular dial. And when you got back to the channel you were on, you would decide what was the least objectionable thing, and that's what the TV would stay tuned to. And when you turned on the TV the next day, it was on that channel. And so that channel got a good lead-in boost as well. Today, with a universe of thousands of channels and video on demand, people may not be any more picky than they were, but they don't have to be particularly picky. They can go to one of another 1,000 channels rather than one of another channels to get what they're watching. And so capturing that audience is a big problem.
Do you see a solution on the horizon?
I do not see a solution on the horizon because I don't think that we as an industry seem to be that concerned about it. We're more interested in moving technology than we are in capturing audience.
Okay. All right. All right. That brings us back to John. What I'd like to do is ask another question to go through the panel here. And this question is, talk about the situation we're in right now, collectively, as a whole. What's it like? Are we in a time of massive chaotic change? Or is it just kind of routine, only there are different technologies, so we're not quite familiar with them, but it's pretty much routine? I mean, those are two extremes. Put your stake in between those and tell us where you think we collectively as an industry are with all of these technologies in transition.
Me?
Oh, sorry. There's three Johns.
You didn't identify the correct
I broke my own
John.
rule
Yes,
here.
right.
Sorry.
Well, I wanted to follow up with what Mark said about the people in New Zealand seeing something different than the people see in England or the United States. BBC did Wolf Hall. It was shot in HDR. It was lit with candles. Many people who did not have HDR felt that the picture was way too dark. They couldn't see any detail. And the metadata that follows HDR is supposed to control the TV set, at least in part, so that the director's intent is what comes through at the end. Obviously, that has to be an HDR TV. And so it's one of the things that should make the viewing environment more similar. And the other problem is PQ by Dolby was pretty much developed for cinema. It is a completely controlled viewing environment. Television is an absolutely uncontrolled viewing environment in every way. There's interstitials and programs, all the blinds are open, the lights are on in the room, you're sitting way off axis, there's a million of them. And so what we do in television has to be quite different than what is done in cinema.
All right, John, I'm not going to let you off the hook, though. Tell me where you think we are as an industry. I mean, you visit a lot of television facilities, you talk to a lot of people. Do they feel like we're in a massive, this John right here?
Still, okay.
Do you feel we're in a massive, chaotic transition of many different technologies, or is this kind of routine and we're just not familiar with it just yet?
Well, you know, there's an old saying, the only thing that's constant is change. And so we're in it, and we've always been in it. I think there are more simultaneous technological changes, and certainly ST2110 is an entire paradigm shift. It's not just an improvement. It's not a little better. We've been improving the television pictures since 1930. But ST2110, that's a big deal. That's really different than, and the skills that we have to deal with it is really different. So I would say that it's more simultaneous technological changes, and at least in the case of ST2110, it's a much larger change than, well, certainly much larger than the transition from analog to digital.
Amen. Okay. Carl, want to take that same question on?
The thing about SD2110, since we're picking on it at the moment, there's not a substantial change, if any change, in the image quality. The end viewer doesn't know that they're watching something on IP versus SD. They would probably notice as if it was analog, because there's a roll-off or a frequency difference there, but the 2110 suite was really designed to emulate all the things that we've done in the SDI, at least from the visual environment, and from, in many cases, the workflow environment right now. I think that'll change over time. The technological changes that are happening, though, with 2110 is an educational one. And it's an educational from the workflow capability standpoint, from the technical standpoint, people having to learn things. There's an uncomfortableness level there. There's the facts that there's little nuances in every type of installation. I don't think any two installations that we've done, and I'm looking at some of the guys in our company here, have been the same or will be the same. Even if you say you're going to build almost identically the same plant, just the same software versions from 3 months later till 9 months later are going to make a substantial difference. So it's a combination of things from the technological perspective that all are gears in the transmission, so to speak. That's probably the best way to. You don't really know what's in your transmission. You got a bunch of gears. You don't know what sizes they are and how they mesh together until you step on the gas and see whether it goes anywhere.
Wow. John Turner? Oh, the question, just put a stake in the ground. Total chaos of figuring out all these new technologies, pretty much routine, only a few changes. Where do you think we are with all of these technologies in transition?
I think it's great for all of us in this business to have it available as long as the bean counters will pay for it. But I agree with Mark that the problem is the viewing. I mean, we watched Game of Thrones, and my wife complained about the black level on the thing, and she's smart enough girl to know what the words are. And she said, yeah, crank the black level up on that monitor. I said, no, go downstairs to the plasma and turn that on. She says, but she did, and then she was happy enough when she saw that. But then she came up and said, how come this is being transmitted like that? I said, I can't answer that question. But, there's so much going on, and I think for us up here to be working on this, we're lucky guys to have this opportunity because we get a chance to use our backgrounds and our technical smarts to solve some problems. One of the things that was brought up before was 5G, and when that was announced, I've got a good personal friend named George Hoover, and I see George quite a bit, and Nancy held up her phone and said, George, this is your worst nightmare. Because and sure enough, 6 months after we were with him, I forget who it was, but there was an NBA game shot with cell phones, partially, and I don't remember who did it, but and they were locked down, but they were, and I don't think they were 5G. I think it was just standard stuff.
No, they were 5G.
So,
They were 5G.
was it?
Was it bonded cellular?
5G.
No, it was just individual phones.
Okay.
Yeah.
Okay.
The thing about 5G, though, remember now, that's a double-edged sword for us. So far, we've only discussed 5G from the acquisition side. On the distribution side, the ATSC3 people, some of them, seem to think that this is a wonderful match to 5G. Now, let me throw this at you. Suppose you're Verizon and you make money selling that service, and I come up to you and say, all right, I want you to put this chip, I'm going to give it to you for free. I want you to put this in your cell phone so your customers can watch over-the-air television for nothing. What do you think the reaction would be? I think I know what it would be. I mean, you don't need an MBA to know that. So there's a few people in the business pushing this, and I don't see a future for it. I don't think it's going to go anywhere, but we'll see, I guess.
Stay tuned. Okay, John? Oh, Maya?
It's not chaos.
Okay.
It's
Tell
not
us about
chaos.
that.
We've got choices to make.
Okay.
And so when it's time to, when your bean counters all line up and your budget comes together and your facilities people say, hey, guess what? This building is worth more without us in it, or whatever. These things happen, right? There comes a day you have to build something. And so when that time comes, right? Everything before that is just talk. Everything after that, hopefully, is an operating facility. But when that day comes that you say, okay, we really do have to build a new studio or another newsroom or reorganize this or move the whole place or whatever it is, when you can't put it off any longer, then you say, okay, we have to build this. It has to go live on date X. Then you look at all the different ways you could do it, and you do the engineering work that you get paid to do as an engineer. You come up with the best trade-off of those things, right? And that's what we've done in television for years. There was a last analog facility in New York. Somebody built it, right? There was that moment of, maybe 18 months or 2 years or whatever, that D2 was the smartest, bestest thing you could build, right? And it was a period of time that if you had to build it then, that was the right technology, and you did it because it was the right thing to do then. And that's true of everything, right? So before you have to do it, it's good to learn. And after you have to do it, you hope you made the right choice. But in that window where you really have to do it, that's when you finally have to put your money, take your chance, and each of the technologies has to stand up and make its difference for you. So it's not chaos. It's just there's a time when you have to really do it. And that's when you make your choices. And before that, it's education.
Well, the reality is that in the typical life of an engineer, they spend very little time building facilities. I mean, system integrators, that's their line of work. But most broadcast people work in a facility that gets rebuilt every 10, sometimes 20 years. And their life is pretty routine, working within the context of that facility. So a lot of the talk and conversations and trade press and articles and SMPTE meetings is about people who are not in the middle of a build. So you're saying that the people who are in the middle of a build have a fundamentally different perspective than people who are just in the general industry going about their routine business? Is that your perspective? Or
Yeah, I mean, it's really that when you have to choose, you look at all the things that are on the table at that time and you make your choices. And before that, it's all about learning what those choices might be and following the trends, and you'll see things come and go. And, if you made your list a year ago, there were things on your list of technology things that weren't on the list a year ago. And there's ones that won't be on the list next year, right? Think about like 3D, kind of came and went, right? There's a few like that have come and gone. But when it's time to build it, you have to make your choices based on where things are that day. You can't, but that process we're in now for all of us the rest of the time, right? You're figuring out, what's new, what's there, so that when your boss calls and says, hey, next spring we got to do it, you're ready to go do it.
okay.
That's really the point, is that it's this education process where we keep fresh on the new things is super important, because you may not get a lot of notice. It might be that phone call comes tomorrow morning and says, hey, guess what? I made a deal. We sold the whole place. Next spring, we got to be out, or whatever. That happens for non-technical reasons that can't always be predicted.
Carl, looks like you want to jump in and say something.
I wanted to say, isn't 5G going to fix 3D?
Okay, good one. Okay, Mark, massive
I'll answer
chaos.
Carl first. In a word, no.
Thank goodness.
Um,
There's actually talk at CES again last week
I'd
about
like to
3D
talk
again.
about-
In a couple more years, it's going to come back.
There's an audience problem with 3D.
5G will make it possible.
Okay.
How many people here have a refrigerator? You have an icebox. Do you? Does somebody deliver ice to you every day? Okay. Well, let's talk about that difference there. Jim has an icebox. If you peel an orange and eat half of it and put the other half in a refrigerator, it's going to dry out. If you put the other half in an icebox, it doesn't dry out. So every advance in technology has some negatives to it. Back in the days of tube cameras, when I was at Sesame Street, If we wanted to do a dream sequence, we injected an audio signal into the scanning circuitry, and we got a dream sequence. It's not something you can do with a chip camera. But we still went to chip cameras, and since I think Jim is probably the only person in here who has an icebox, anybody else? So we all made the transition to refrigerators because we decided that the drawbacks were overwhelmed by the advantages. How many people here have a microwave oven? Pretty much everyone. How many people here have a conventional oven? Pretty much everyone again. Okay, that transition didn't happen the same as the refrigerator transition. We have a microwave oven because we can do things with the microwave oven that we can't do with the conventional oven, like very quickly heating up a cup of coffee, but we can't do a roast turkey in the microwave oven. We do that in the conventional oven. So that became an adjunct that we added to the kitchen, not something that replaced the conventional technology. How many people here have an induction cooktop? A few people have it. Okay, brilliant technology. You can have a little baby wandering around the kitchen and stick its hand right on the cooktop and not get burned. It's brilliant. It's absolutely terrific. But the vast majority of people here have not gone to that technology yet, even though it's been around for quite a few years, because it requires some ancillary stuff. It requires specific pots to be used and pans. You can't use your conventional stuff that you've been using. So this is like the converters that you heard John Turner talking about in the system that he did that ended up being SDI. You would need a tremendous number of converters to make everything work with the IP system. So the big question that we have is not whether there's chaos. We've had the same chaos in kitchens that we've had in TV studios, but what is going to be the refrigerator, what is going to be the microwave oven, and what is going to be the induction cooktop? That's what we need to figure out.
Mark, could you kind of focus more in on the state of the industry and just how we're doing?
How about the refrigerator?
I know, but I love the analogies, but bring it right down to earth for.
Okay, we were talking amongst ourselves before the meeting started about my quote-unquote day job, my main client these days, which is Metropolitan Opera, and they are doing something now that first appeared in the New York press in 1877, which is sending operas live to theaters around the world. And we're going to something like 2,400 theaters in something like 75 countries on all 7 continents, including Antarctica. And it's an ad hoc network because it happens only 10 times a year. And so we do testing for an hour before each show to try to get people to make sure everything's working right. Well, one of the things we want to make sure of is that the audio and video are in sync. And we have these 2,400 theaters, and we're getting there by advanced technology. We're using advanced technology in the production, but we're ending up in a theater maybe in Tajikistan or someplace in the United Arab Emirates or someplace in Ushuaia, Argentina, or at a Argentine research station in Antarctica. How do we do lip sync for all of those places? The only thing that everyone agreed on was a clapstick. The Germans are very upset with us for using the clapstick, although they use it and they can verify lip sync with that. They want us to use some automated system. So we added an automated system for the Germans. But the people in Antarctica can't use the automated system. And so we've got to deal with advanced technology and basic technology at the same time. It's the Game of Thrones HDR problem. We want to deliver HDR to the people who can get HDR, but we want to deliver something that the audience is going to like to the people who don't have HDR and don't have the metadata. So as we advance technology, we can't forget the stuff that requires old technology.
All right, before we turn the questioning over to the audience, does anyone on the panel have anything they'd like to add to the comments they've just made? John? John Humphrey.
Earlier, it was mentioned that the transition to ST2110 really has little effect on the end user, the person at home watching TV. I think as Carl said, it's still the same picture. It looks pretty much the same. And so I guess you'd say the onus is on us to make that transition. The people at home don't really have to do anything. HDR is exactly the opposite. That is to say, HDR has been in our cameras for 3 years. We didn't change the price. Modern CMOS and CCD imagers can always do a lot more than we're allowed to do by 709. So we just unlocked it and made it available, and so did everybody else. So the onus is on the display. That's the people at home with their TVs. And as you know, if you buy a name brand 4K TV today, it has HDR. There's here's the problem, 1.6 billion TVs in the world, and probably 1.5 billion are SDR. So it's a little issue that we have to deal with.
Just to add one more thing that I neglected to say, that there is an advantage to the 2110 platform that you can't get very easily with an SDI, and that is it does give you the ability to do 10 or 12 or beyond bits of capability inside the production plant, which is necessary for HDR.
Okay, good. Anyone else?
I'll just ask John Turner, when you said you were considering doing 2110 or IP for the facility, that you needed to consider 2 IP routers. Could you explain why you wanted 2 IP routers instead of 1?
Well,
Carl,
really more of a question for John Myatt, but I'll take it first. I could be a smart aleck and say, yeah, because it doesn't work worth a darn without it, but I think it's because, if you have a glitch or a hit in a system like this, I mean, some of these large switches can take 20 minutes to come online. Can you imagine having an outage that long? Your customers would be gone. So having a redundant system avoids some of that problem. Now, John might know more of a salient reason why every 2110 plant that we've either been in or worked on has been redundant.
They're not all redundant. I mean, I know a couple of fairly large plants that they, cost engineered out the redundant switch. And they wired for it, like there's fibers there, but at the end they said, oh, we'll just half those SFPs and that big extra switch, there's a spot in the rack for it, but they at the end cost engineered it out and said, how often is that going to fail? And we said, well, it shouldn't fail ever. Okay, great. But if you have, like in that particular plant, they have, a lot of maintenance time, right? Because it was a place where they're only on the air so many hours a day. So the rest of the day, yeah, they got all kinds of daytime to do software updates, whatever. But if you think about an SDI router, every spec I see for an SDI router says it has to have redundant crosspoints, right? And so this is the equivalent thing, really. It's the equivalent of redundant crosspoints. But instead of just covering a little thing in the middle, it covers all evils because it covers the wiring, the optics, the crosspoint, and a fair bit of the control logic.
And comment.
Well, only if you hook up the power correctly.
So my point on that is your PR department wants you to be the first with something, whatever the technology is. We are the first station to use this technology. We are the first studio to use this technology. We're the first TV show to use this technology. Maybe your engineering department wants to be first also. Hey, I was the first to use the SFP clock, or I was the first to use this other new technology. It was really cool. But your operations department wants to stay on the air, and they would love to be the second successful facility with any new technology, not the first.
I have to explain to the engineers inside our company that they think that customers are just cheap and they just don't want to pay for anything. And I keep saying, no, it's actually not the issue at all. Our customers, y'all, for the most part, one of my models is that it's risk avoidance, right?
Yeah.
It's risk avoidance, and it's how many seconds of downtime a year is acceptable. And the answer is 0, but like 1 or 2, you might still be employed next year. So it's that aspect of, what differentiates the, television engineering from sort of some of the more traditional IT approaches, or the, say, Netflix, YouTube, some of the new stuff, is this notion that if 8 or 10 million people are watching the network, boy, a second of downtime is like a really awful thing, right? But, Netflix, they were down for a whole night a year or 2 ago. Remember that one? Somehow they lived through it, and the person who figured out how to get them back up, he got a gold star. So it's just different businesses, right? I mean, a lot of the new viewing is this OTT stuff. Well, it's not currently being engineered and delivered with the same kind of reliability model that we have in the OTA television industry. But as the viewers shift there, which they inevitably will, it will be engineered to that level, because ultimately it'll be required.
Okay. Carl, looked like you had a question before you gave up your mic. No, we're good. Anyone else? Okay, so we're going to take some questions.
Let me get one of the mics. So
Oh, great. Thank you. Excellent. Okay.
here we have one right there from there.
Taylor questions.
Hi, thank you guys for all of your input. Larry Thaler from the Video Call Center. This question, I guess, is for John Malliot, but it could be for anybody. And as we go to SMPTE 2110, we refer to having new skills inside our maintenance teams or our support teams. Has anybody cracked the code on how to recruit those people and where they come from, or how to retrain the engineers we have now?
Yeah. Well, no,
either side.
It's all three. So it is people that are, mid-career people in television can learn IT skills pretty well, really can, especially when it becomes important to do so. Every project we've done, my experience has been that somebody on the team that's there at the beginning of the project decides that this is going to be their opportunity to really understand it, to be the person that is the expert and that everyone else looks to get it done. And that person, by the end of the project, winds up getting promoted and runs the maintenance team now or whatever. And so people self-select, right? And the same thing happened when we went from analog to ATSC. Some people said, I'm going to be the one who gets that digital stuff going and makes it go. And some people said, I just built a cottage out on Lake Monocacovi and I'm going to go live there. It's a self-selection thing. You can certainly, there are people in the high-end IT industry that understand how to do 24/7 IT. But, they all work about 33 blocks that way and they get paid a lot. But their engineering of their networks is impeccable.
Right.
Because, what's the one thing worse than having a second of downtime on broadcast television? Having a second of downtime on a trading floor. So, it can be engineered super well. And there's people who know how. And they use, by the way, the same hardware that we're talking about using. I mean, there's a lot more of these giant Cisco switches down there than there are in television plants right now. And they run 24/7 with all kinds of money flying through them.
I guess the question is, how do you recruit younger talent to come into our industry? Carl, you made a comment to me a while back about, you ask a millennial, what is high technology? And you say, oh, all these great TV technologies, that's high technology. And they say, oh, I don't know about that. Look at my cell phone, Carl, do you have a comment or two about the perspective of younger people on technology that you might share with us?
Take the younger perspective in there. They didn't know the old ways. They've been grown up around cell phones the majority of their life. They've seen it, so it's nothing new to them. If we take ourselves back to the days of dial-up 48-volt POTS lines, a lot of people today don't have a clue what that is. They look at that device and wouldn't know what it was unless they saw it in a motion picture somewhere. I mean, things come and go as time goes on, and I think the same thing's happening from the recruiting and the education standpoint. As John just said, there's a lot of kids looking for work right now. Some of them have gone out and taken a $90,000 job in Silicon Valley and found out it cost them $180,000 to live there. Well, that's real profitable. And there's plenty of opportunities, I think, in the emerging and continuing to emerge content delivery and creation.
Okay, we have a question over here.
Okay, first off, to comment on that last question, there's also a benefit of an engineer knowing where they came from, and the old technologies help out to understand the new. And I want to point that out. But as I've been studying up on 2110, 2110 was designed almost to be future-proof, that if newer technologies can be introduced more easily, except that I see a flaw in it, that it never really specified what happens on the next category of network wiring that comes out or so forth. And how are the systems future-proofing against that?
Actually, nothing in 2110 says anything about the physical layer. It's defined on every kind of Ethernet that'll ever exist. It's defined already for 400 gig, right, or 800 gig, or a 1.6 terabit, or you name it. There's nothing in the 2110 that deals with anything below IP packets. So our presumption is, as people make the 1.6 terabit links or whatever the next thing is, that they'll have a mapping to do IP over it, and that's where we plug in.
But the way I was reading it, and I could have been reading it wrong, it's taking into account IPv4, it's taking into account IPv6, but it's sort of like roadblocked on anything future, or am I just missing something?
There's no work in progress beyond IPv6. I think the bulk of the focus in the IETF is making IPv6 be finished.
Anyone else have a question? Over here.
Yeah, talking about cell phones, and I couldn't help thinking when you brought that up that the cell phone in my pocket costs over twice what I've ever paid for a television. Mark, you brought up audience, and one of the transitions I thought was kind of interesting, or one of the things I thought was kind of interesting at CES was people starting to invest money in content for specific platforms, specifically Katzenberg and Whitman with this QB thing, or Quibi, or whatever you say, which is 10-minute chunks, cell phone only, and seems like there's a lot of money going into it. Do you have thoughts? Is that relevant to the conversation?
I always had thoughts. It's a question of whether it's going to catch on this time. You may recall back when 24 on Fox was a big phenomenon. There was a mobile telephone version of 24, and this was in the era before smartphones. So it was just picture phones, but you could see the mobisodes, as they called them, for mobile episodes of 24. The gunshots had to be louder. The holes had to be bigger. There had to be more blood, and the typical length of a mobisode was 1 minute, so that you didn't strain yourself holding it. Could be there's a market to be had for that. Along the same lines, are we 16:9 world these days, or are we becoming perhaps a 9:16 world? Since that's the nominal smartphone shape, and if you walk through Manhattan, you'll see on the street furniture an awful lot of video that's in 9:16 mode. We had a discussion at the HPA Tech Retreat a couple of years ago about how much 9:16 there is, and there's a tremendous amount of production that's going on in 9:16. There are sports shows that are being produced in 9:16 now. So, yeah, there's lots of markets, there's lots of ways to make money. Whether they last, whether they become dominant, that's a different question.
Another question over here.
Yes, getting back to Larry's comment about defining the next generation of person. Say person instead of saying technician or engineer.
Speak up a little bit. Hold the mic closer to you.
Okay.
Yeah, good.
So one of the big problems that we had in recruiting last year, I was looking for someone very current skill set, familiar with virtualization, heavy Cisco guy, for a broadcast facility. The job title was technician. IBW position, very well compensating, but trying to find people that would even talk to HR after they saw that word technician was a nightmare. Everyone wanted to be an engineer, network engineer. The title was really off-putting to many people. And we weren't selling our industry as a high-tech field for, say, the kids to get into, because they looked at being a technician in broadcast as old school. It wasn't something that they were into. Explain to them, look, I need somebody that knows Java. I need somebody that's familiar with virtualization. Those are the skills we were looking for, but the people just didn't want to hear about, oh, I'm going to be an IBEW technician, even though we were paying significantly more than most of the network guys would come in at. And tell them, look, you're going to get overtime. Look at this. Instead of just being on salary.
Did you try changing the name of the job opening?
I went around and around with HR trying to do that and kept running into roadblocks. It was a challenge in positioning the opening to get the right talent.
Wow. Yep. Okay.
Anyone else?
Next question we got over here.
Bit by bit.
Hey, how do you see with ATSC 3.0? I have sort of been following the development of it, and I don't have much experience with it. It seems to me that it was designed for a purpose of monetization. Can you hear me okay? Okay, good. It seemed that ATSC 3.0 was designed for monetizing content, specifically for advertising, and that is looked like the focus of what it does. How do you see ATSC and IP delivery competing with each other, living together? Does ATSC necessarily make sense in an IP in a 5G world?
Well, that, the over-the-air broadcasting that we've had has been relatively constrained since it went on the air as a digital signal. And there's an a number of cord cutters that are transitioning back to antennas. I think the numbers are probably higher than are advertised, from what I understand. I don't know how you feel about that, but I believe that's the case now. ATSC 3.0 will give a little bit of parity to broadcasters to compete a bit with what is coming with over the top and what we have with over the top. The system as it's currently shaping up looks like the receiving device may not be a television set. It might be a gateway that you put in your house where your router is from your internet delivery service. And you'll connect these together, and then from a IP-enabled receiver, you'll be able to choose anything you want, whether it's an over-the-air channel or whether it's something that's streamed. So that's the way it looks like this may go. We'll find out. We're going to try something like that at the NAB this year, and we'll see how it works. So.
Anyone else have a question?
I guess the real question is, what's the real business case behind ATSC 3.0?
I think there's a number of them. I think the first business case is to remain competitive with the alternate forms of delivery. People have been complaining for years that they don't get a good signal. People that were empowered with analog, remember, you had analog television, I don't care where you lived, you're going to get something. It might be noisy or snowy or ghosty, but you're going to get a picture. You can hear the news. You can watch the weather. With ATSC 1.0, when we went digital, and I don't think we're really prepared for this, but when this went on the air, I mean, you either have a perfect picture or you have nothing. It's one of the other. You have a cliff, and sometimes it's hard to know where that cliff is. It's not as easy as taking a 50-foot of coax to find out whether you're at the end of your SDI range or not. So this is going to fix a lot of that. The signal's much more robust. And again, as I mentioned earlier,
Just moving the cliff.
Well, we do have LDM, and broadcasters can put up two streams. They can put up a high-quality 4K signal, and they can put up a very low bit rate, very robust signal. But we'll see. Now, the other thing that it does is it enables some of these advertiser features, some of these directed ads that are possible if you connect your receiver to a gateway. But again, it's still a one-way service. The over-the-air signal is still one way. There's no back channel. So I don't know. I mean, it's a good question.
So, again, are the broadcasters going to be able to deliver what ATSC 3 promises? Will they have an infrastructure and a sales system and be able to monetize these services as broadcasters are today? Maybe other than Sinclair, who's behind it, but the rest of the broadcaster universe, will they be able to take advantage of what ATSC 3, and will they have the back office infrastructure to be able to deliver? Silence.
Hold on, let me.
Well, I'll say on the back office infrastructure side, that's been a big focus of ours. Actually, is on it. It is hard, right? Because it's hard enough to prove you ran one ad.
Correct.
But to prove that you ran an opportunity that was then fulfilled in all those downstream things, it is a challenge, right? And it's a different way of selling, and it's a different, it's an impression-based thing, which is how everybody outside the U.S. actually sells ads on television, but in the U.S. that's like verboten for some reason. But it is the back office infrastructure. This is a huge point, right? It is a big change, and it's a change in what you sold. It's a change in how you prove that it was fulfilled. It is an infrastructure thing. You have to ask your traffic system, hey, how are we going to reconcile this? How are we going to bill it? So no, it Ken's onto this, that there is work in that. And by the way, it's common work with OTT delivery in general, where you have to prove there was an avail. It's just that in that model, usually it's disintermediated somewhat. So like if ABC puts a spot or a place that can get replaced downstream, they get a cut of that eventually maybe, but it's somebody else's job to fulfill those ads and prove they ran. It's downstream. But in ATSC 3.0, that actually comes upstream to whoever ran the antenna. And are they ready at, KZBQ in Des Moines? Are they ready? They could be ready, but it's work.
If the sales department doesn't want that, it won't happen. The sales department is the one that's going to drive the business rationale for making that leap.
Or not.
That's right.
At
That's
the
right.
risk of pouring cold water, as long as the television industry operates on scheduled programming, and today most people want anything, anywhere, anytime, there's a fundamental problem. Regardless of the ATSC 1 versus ATSC 3, I think that the broadcasters who finally moved to ATSC 3.0 may continue to operate the way they have since 1930s with scheduled programming, and that's not the model today. Sorry.
Mark Foreman.
Okay, thinking about the future, what's the 8K game plan?
Go to Tokyo and watch the Olympics.
Head over to Japan.
I think we're going to see in the next 3 to 5 years, probably every fab plant making 8K.
Oh, of course.
And which means there's an opportunity there to pick up on the receiving end. People go, well, there's no content. I'll tell you, if you see good 4K on a 4K and put it side by side with an 8K, same data going into it, you'll see a remarkable difference. You'll see some of the Nyquist limits go away that you see in 4K. And if you rewind a couple of dozen years or more, when HD first came out, everybody looked at that and said it's like looking out a window. You put HD next to 4K, it's not like looking out a window anymore. That's my...
Hey, Carl,
Well, since John Turner brought up George Hoover, Tom Sahara said 8K will never leave the truck.
Gary Olson has a question.
I just made a statement.
Oh, you did? That was you. Okay. Oh, that was it. Okay.
All right, we had one over here.
We've got.
Yes.
I just want to make an obvious point that the display 8K is disconnected from the resolution of the image. When Apple came out with Retina displays, the whole point is that you wouldn't see a pixel. Someday little kids are going to say, Dad, what's a pixel? Because they never saw pixels. If you stand up next to an 8K screen, a few feet away, you won't see the pixels. That's the point. So most of the theaters in town, commercial, motion picture, they're showing 1080 lines. They're showing 2K on big screens. And you don't see pixels. So why wouldn't we want a very smooth display at large size in our living rooms to watch HD on? Why wouldn't we want that? So just because they're making 8K panels doesn't mean that we have to shoot 8K. That should be an obvious point. They're disconnected, but I never see anyone make that distinction.
We've already made that distinction in 4K, right? You can't buy, if you go to Costco, you can't buy a TV that's not 4K. But you take it home and you can't find a content that is 4K. And yet, you hang it up and it looks darn good.
Well, remember what I said about viewing distance. So an 8K has to be, a couple 200 inches diagonal at 9 feet to make any sense at all.
Right.
And if 8K is expensive, imagine 200-inch diagonal 8K. So if you have to ask the price, you can't afford it.
The point is that this thing will take a 4K motion picture image. So what? We don't have to transition. We can shoot with 8K cameras, but that doesn't mean we have to deliver in HK.
Yes.
Good evening, everyone. My question is not technological, really. I am a woman, a small business owner. I just decided to quit my job 1 year ago, and also I'm a student. But I am in the point right now, after 1 year and open my own business, that I need to buy cameras, right? I need to shoot because the whole last year was try to learning how to run the business. That I spent my whole year. So now is the time after the education to do something. For me, what kind of camera do you recommend? Because I'm gonna start right now. The action is gonna start.
Yes, John.
I'm sure there'll be lots of advice after the.
Stay after the meeting. There's a few people with opinions on that. So we can come back to that.
Hi, sort of a general question. I'd like to know what everybody thinks about the reliability aspect of the delivery side here. When we have over the air, you have a TV antenna, you're responsible for just your down lead, you're done. And it comes to your TV and it works. When you have an internet supplier, that doesn't necessarily always happen. It's very inconvenient. You're going to wait a lot of time for these things to load. They crap out in the middle. You never know what's going to go on. You're going to have backup programming available when you want to watch TV. So could you comment on why we want to sacrifice the over-the-air reliability for a gateway IP system?
Is there a question? I mean, it's
a number of channels. I mean, you know, I mean, why did cable come along as it did? I mean, it started out solving a reception problem, and then it transitioned when HBO got a transponder on Satcom 1. Everybody's like, wow, look at this. You know, we'll buy this. And it grew from there. Now, how many channels can you receive off of a cable feed? Hundreds.
Okay. Before we take the next question, let's just remind everyone, we're focusing on technologies in transition and how they come together to build facilities. So if we could stay focused on the topic that we're covering, that would be great. Anyway, anyone have another question, please?
I don't see any other questions. Is that true?
I'll take one.
Oh, it is Rich. We have one here. We have one from Mr. Rushton. Hold on.
So you guys have been a little quiet on the term the cloud. So where do you see the cloud in real-time television origination, production, and delivery in the next 24 to 36 months?
Well, Fox announced they're going to stream out of the cloud to their release systems. So I think they've done their homework and they're convinced it's going to work fine.
You think so?
Having a good bit of experience with telcos, I'd be real worried about that. I'm not at all worried about the streaming service or the cloud services. I'm sure they're rock solid because in most cases, those things are supporting other, take Amazon for a minute.
Yeah.
You know, they're supporting their business. But, you know, you've got long distance carriers and then you've got local loops and you may have more than one of them. And, you know, you can have the best SLA in the world. And you know, it would scare me quite a bit to be a broadcaster that's relying on something like that. Although it's extremely redundant.
Then again, your air chain already is extremely redundant in-house, right? You have an A list
In-house.
and a B list and a backup list on that. I mean, I've seen, you know, typical broadcast behavior in New York is you got 3 on a lot of things, right? Now, when you do that in, say, Amazon, that means you group one of them on East, you group one of them on West, maybe the third one you run on a server in your own basement. So you gotta, like anything, you have to engineer it. And there's no free lunch. I think the best Dilbert I saw was actually the one where it says something like, you know, there is no cloud. It's just somebody else's computer. And so, like, the economics of it, if you're going to run a 24/7 service, or, you know, do your math on it of all the things you're paying for, the bandwidth, the hosting, all the pieces, and decide if you really are saving money versus buying stuff and sticking it in your own data center. You know, if you don't have a machine room at all, okay, that's a different trade-off.
Right.
But if because of news or other things you're going to have some machine room space, it's a, you know, like everything, engineering involves like doing the math and engineering the reliability you want. Can you get that reliability with hosted in Amazon? Absolutely.
Yeah,
Can
pay
get
for it.
it
Are you willing to
hosted in
pay
your
for it?
basement? Yes, absolutely. But they each have a cost point.
How much of the cloud issue is about transport between your facility and Amazon's closest center? Is it, I think we went through a phase about 5 years ago where
Yeah, you can provide different levels of that, but let me put in a shameless plug. The morning of February 20th at the Westin Mission Hills in Rancho Mirage, California, the HPA Tech Retreat will be devoting half a day to transition in the cloud based on the Movie Labs Vision 2030, which is not merely cloud, but collaboration in the cloud. So it's not just your version of cloud, it's everybody's version of cloud. And it will include the transitions that PBS is making to cloud, that Fox FX networks are making to cloud, and a bunch of other stuff. So again, Thursday, February 20th, HPA Tech Retreat, Westin Mission Hills, Rancho Mirage, California.
You're welcome, Mark.
It's not sold out yet, but it will be sold out. It's been sold out every year for the last 20 years or so.
Okay. Any other questions?
We have one there.
Over here, we have a question over here. Do we have a microphone? Okay, go for it.
Hi, my name is Alex McGregor. I have a question about PTP. I'm interested in, when I first, I've read articles about it.
Speak up a little.
Okay, sorry. I've read articles about it, and one of the solutions it was supposed to solve was the audio-video delay, and also to simplify remote broadcasting so that you wouldn't have a frame sync, but a buffer to bring it in line with the plant. I'm curious about which, if there's some facilities that are more advanced with the PTP than others, like maybe Carl from Diversified or somebody who's like, I don't know, like may have more familiarity with the latest PTP installations.
John.
I'll say first, any SMPTE 2110 plant is doing PTP, and it's PTP v2. There was an old.
Yeah, I'm familiar with one, and they used a lot of hybrid they used cards to convert to Blackburst, and I was wondering if there's ones that are, go beyond that.
Well, PTP is PTP. It's in the network. So if you need a Blackburst, yeah, there's gizmos that'll lock to PTP and make Blackburst. In fact, most PTP generators, if they're designed for television use, generate Blackburst and word clock and all those other things too. And it is super important if you have a mixed plant that the two are actually locked together somehow. You either drive your PTP from your black or you drive your black from your PTP, because if they're separate, you get all kinds of interesting problems. But it's, there were some rocky times, I'd say 2 years ago, but every plant that's doing 2110, every plant that's doing anything with AES 67 is in ATSC3 for that matter, are doing PTP v2, and it works fine. I'll say, like I said a minute ago, like anything, if you want it to work reliably, you have to actually engineer it.
Okay, we have a question over here.
Yeah, Ellen Ryan. I know that an operating system, they might provide and update a patch for security reasons or whatever, and it looks really innocuous. How do you test keeping the system up, but still test to make sure it's not going to bring down your system accidentally?
Once it's built, don't do any patches. Don't do any upgrades.
I mean, I've seen that kind of thing
Everyone in this
happen.
room that works in television can tell you horror stories of having the automatic updates turned on a mission critical machine. You know, oh yeah, I just hit the OK button on that and putting the whole thing off the air.
No, I've heard of that happening. That's
Yeah,
why I'm asking. This is a much more complex system.
You've got to be very, very careful with this stuff, because you're probably running applications. This is not an office computer. You're running applications that are either real time or mission critical. And I guarantee you that the manufacturer of your operating system doesn't have that software and has no clue what's going to happen when you do those updates. And, you know, unless you've got a really big lab, and there aren't many of them left anymore, where you can test this thing under all kinds of conditions, I wouldn't do it. My recommendation is don't do it. If it's working, don't fix it.
Sometimes you can't avoid it.
Okay.
Here, we have a new.
Okay, Carl, do you have a comment?
Yeah, I mean, that's frankly one of the reasons that you build, we'll call it the red and blue, or in Europe, it's the amber and blue networks. You build something, you build a mechanism, and you do it by engineering your system so that you can do the appropriate updates without necessarily taking the other system, the other side down. You split it, you work on it, you make sure it works, or you build and our recommendation in larger facilities, to put a sandbox together that is identical to what you're doing on your online systems, and that's where you do all your testing. And be sure that you know how to do a regression test. Don't put something in there that you can't reverse. There was a while ago when there was a product that if you once you started the upgrade, you really couldn't turn it back. You want to make sure you haven't picked that particular product, and then you have to work with every one of your vendors to be sure that they're going to qualify that system ahead of time as well. And I think that's going to be the change in the industry, or at least some of the roles of a system integrator. They may be helpful to the vendors from a clearing point. I know we're doing that right now in some of the projects that we're underway.
Backups and images are the most important thing.
Right over here.
Hi, I have a question about future-proofing your facility. In terms of designing a facility for the future, right now there's a lot of focus on moving away from coax and moving over to IP. But in terms of future-proofing, does it make sense to have to include coax in your facility design in case something goes down, or there is a problem with the switch or the router, or there's something happens in the physical network layer that you would want to have a fallback using coax?
That would mean you'd be building a duplicate facility, assuming you're going to use SDI as the alternative. You'd have to build two facilities in many cases, or you engineer it so that you can fall back to something.
You don't have to build two complete facilities, but you can decide what is the absolute minimum that I want to keep going when my main facility has gone down. And if you look, for example, at the mobile TV group IP truck that came out, they have a little bit of analog stuff in it. So they can keep a few cameras up, they can keep a little switcher going, they can keep a little audio mixer going. At the Metropolitan Opera in the radio network, which goes all around the world live, our last desperation thing is a Shure M67 battery powered mixer connected to an equalized telephone line.
Been working that way for 30 years.
We have not had to use it yet, but we have tested it. But the power can go down in the building. The opera can stop. We can still have the announcer telling the people around the world why they're not hearing the opera. So decide what the minimum is, and that's what you have as your backup system.
Flood of 61st Street.
Yeah.
David, you have a question?
Yeah, that's a good entree into what I wanted to ask you, Mark, about the ad hoc network that you mentioned. I saw Bozak on Saturday, the William Kentridge, and there were cameras there, and I was pretty sure that was one of the live transmissions?
Yes, it was a live transmission on Saturday.
Right, I was sitting behind the camera, so I got to see what he was doing. But the question is, to some extent, my question is, which, if any, of these technologies are applicable to what you guys are doing? And secondly, are you using cloud services? How do you time shift? If you're sending a live transmission all over the world, is it being viewed live, or is there some sort of staggering?
It's being viewed live from Vladivostok in the east to Anchorage in the west. And well, actually Hawaii is live also, so Hawaii is a little bit farther west. That's the live extent. We are not live in New Zealand, Australia, Singapore, Japan,
Korea.
and parts of China. And because we're not live in those locations, we can be as delayed as we want. Japan likes to do their own subtitling. We send them the files and they add the subtitles later. Until very recently, we actually sent them tapes because it was faster to get the tape to a courier to get to them than to get a file to them. But now we can do it with files. As far as cloud, we do some of our roll-in material coming in through the cloud. We are not doing distribution through the cloud because it's not reliable enough for the various locations that we're going to. For the US, Canada, we could probably do cloud, but we can't go to Tajikistan, for example, on cloud and ensure that we're going to get there with high enough bandwidth to not have glitches. We are very interested in HDR, but we have a display issue. We've got those 2,400 movie theaters with who knows what they have. Similarly, we'd love to go to 60p, but we have a display issue. We have no interest whatsoever in going to higher resolution than HD. Resolution is absolutely fine. What other technologies are we talking about? Oh, IP?
About 22.1 sound.
Yeah.
What would qualify?
5.1 now.
What would qualify for HDR in the theater? Would be an RGB laser projector?
It depends. You know, we're willing to let somebody tell us what they can do, but it has to be something that can be done in all the theaters. And we've had limited control because we have so many distributors around the world. The one thing that I put my foot down on at the beginning was the projectors all have to be HD, at least. And they were trying to get around that. We had some 640 by 480 projectors when we started.
We're from the same tribe. Everything I shoot these days is 4K RAW, but everything I deliver is HD.
There's one right here.
Thank you. Mine's about power. And I have a question about changing it when you go from taking your XLR and your coax and then you turn it into IP based. And studios, generally, you know, you have your runtime of UPS until the generator kicks on, so your runtime might be 4 or 5 minutes. But if you take this XLR and you take this coax and it's now all IP based and you're getting brownouts, you know, it's a different story, right? I wanted to hear the experience of the power. Does it always have to be double conversion where you're constantly needing UPS on, just like data centers, because your master control now is an IP data center? So I wanted to hear more of the experience and the change of the power side of things.
Do it first. Sorry. UPSs are an absolute must. And sometimes you need more than one of them. And you have, again, as John keeps referring to it, you have to engineer the problem. And you have to think about what type of reliability, how many nines you really need. And you have to look at these UPS systems and you have to choose good ones. I've seen UPS systems that aren't as good as the equipment they're protecting. That's something to watch. But so I mentioned before, the reason that putting in a dual threaded 2110 plant is sensible, because if you do have a hit, you lose power for any reason, the startup time on those things is quite long. The startup time on an SDI switch is maybe a second.
Yeah, I would echo that. You're basically building a hard data center if you want the protection, and across the board, both your A and your B sides. You weren't building an IP plant, IP as in 2110 plant, but you were doing a VM, a virtualized environment. The order you bring those things back up on or shut down on makes a serious difference in how long they're going to put them back up again. So you just don't have any choices in this world.
We have one more question here. Yes.
Now, we've had an effort by the industry and industry members for interoperability. And in the past, it's been, you know, pull out the scope, sit out this, figure out what's the standard and this and that. how have you guys been finding those little bits and pieces that don't work, right? And interoperability between these new plants and new technologies. How's the challenge different?
Well, if you understand what's under the hood of the 2110 standard now, take that for example, you know, little things like the payload IDs that might come up if you didn't check everything in the first place. If you have a 96 and it should be a 97, that whole system, not the whole system, those with the wrong ones are going to not show up very well. So you begin to learn during the commissioning processes of what's important, what to look for, where the anomalies and things are. We had brand new products in one instance where they wouldn't address port 50,000. There's no reason why it wouldn't know what port 50,000 was. We use that number in almost everything we do. And we started ratcheting it down. We just went down, 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 and we got down to like 22,000. 22,000 worked. 22,300 didn't work. It's, you know, and then you work with the manufacturer with that, because that's probably not, it's nothing that you necessarily did wrong. You didn't pick the wrong values, but you need help. I like to call this whole world now the three-legged stool. You've got the end user, you've got the vendors such as John's company, and you've got your engineering team, whether it's an integration team or your own internal. But all three have to work together in order to make this suitable for the long run.
The one thing I'll add to that, we've had a bunch of industry events where everyone shows up at, you know, a place and you plug all this stuff together. Well, we've done Plugfest. We've also done organized structured testing programs where there's an automated test suite and you run things through it. So, you know, we've really done a lot, and there's published results from some of these of exactly, you know, who all turned up with product and how it scored and so forth. So far more than we ever did previously, right? We never did that for SDI. We never did that. The other thing there is now for 2110 and for PTP is test equipment that really works. You know, if the Tech Prism says it's good, or the Bridge Technologies, VB, whatever it is, says it's good, or there's Fabrics says it's good, it's probably good. Like, you know, we've gotten there on that stuff. So there's test equipment that's real and it works, and if it says something's good, it's probably not too bad. So that's all positive stuff, right? But the other thing that's happened is just through the trade associations and things, the engineering organizations and engineering sort of leadership at all the vendors all kind of know each other now, because after all these events, we all go out and drink beer together. Imagine that, right? And so, you know, so a lot of things get sorted out a lot more quickly than they used to, when it used to be that, you know, things had to go up to, you know, VPs yelling at each other, and then it comes ricocheting down into engineering as a, you know, some crisis. We've managed now to achieve a social construct between the engineering organizations. We all kind of know each other, and we can get ahead of problems. Net helps the customers, I think.
Good. Okay, I think we're running out of questions. I'd just like to go through the panel one last time and tell us what you think. How will things be different 5 years from now with regards to these technology transitions? What do you think will be better? Where do you think we'll be in 5 years? Want to start? Okay.
Well, I'm speaking on HDR primarily, and as time goes on, more and more TV sets will have HDR, and currently we're doing a single master approach that is HDR, and then it's converted to SDR at the endpoint. As more and more TVs have HDR, the need to do that is less and less, and at some point, most of the TVs in the world will be HDR, and it will not be an issue that it is today.
Mark, 5 years from now.
My artificially intelligent assistant will deal with everything we've been talking about.
Okay.
I'll ask it more as a question. So how many people here either are under 30 or have children under 30? Okay. Do those children or you actually watch television in a classical sense?
Yes.
No.
All those people will be 5 years older 5 years from now, and they'll represent a far bigger share of the audience 5 years from now. Because the dinosaurs that actually watch linear television in a traditional way will also be 5 years old. The lucky ones will be 5 years old.
I hope I'm retired in 5 years. I'm doing this a long time. No, I'm a little bit disappointed that for some reason this broadcast industry hasn't been able to attract the talent that's coming out of schools. This was mentioned earlier. I'd really like to see some way that we could stimulate that and have more young, fresh minds, especially people that are coming out of school IP-centric already, to join us and join the industry.
Before Carl gives his last comment, I just want to mention that Jeff Cohen is going to have an announcement for us. So why don't you come down here, so we'll be at the ready.
Josh put a lot of topics, I think 12 or 13 different questions or topics related to technology, and we've covered probably 50% of them in some shape or form.
Yeah.
I think 5 years from now, we're going to be faced with similar questions. It's just going to be a different new technology, because things are going to go on. Change is inevitable. Some of these things are going to make our lives a lot easier. Some of them are going to be the same old things we've got today. But it's a matter of how well we embrace it and how much we trust it, and whether we want to, based upon age, experience, and how much time you want to spend with it. Every little system is going to be a little bit different. I think it's not going to be a whole lot different than it is now.
Okay, great. Jeff, you had an announcement?
Yes, so I'd like to ask John Turner to stand up, please. In 2019, this past year, the Society chose to honor and acknowledge John by elevating him to a SMPTE Fellow. He was the only SMPTE Fellow from the country. Got the red pen. So, thank you very much for joining us and congratulating him. Thank you, John.
Yeah, John.
Hey, John.
Anyway, I'd like you to give a round of applause for our panelists here. Really great group. And let's stick around for some questions if you have any additional ones.
Yeah.
It's all about the shows. I don't think you appreciate the value of the
I just stopped working. It was one company for 35 years, and now it's been 3 since 2000. If I find something that's, I don't know. I was gone. Well, most of my sources left this year. I really only know a couple of people. Underside on the blind side. So last time my job was really